This question is from GATE 2013 Mechanical Engineering paper, question number 38. During the electrochemical machining ECM of iron having atomic weight 56, valency 2 at current of 1000 ampere with 90% current efficiency, the material removal rate was observed to be 0.26 grams per second. If titanium having atomic weight of 48 and valency of 3 is machined by ECM process at the current of 2000 ampere with 90% current efficiency, the expected material removal rate in gram per second will be. Let's see how this will be done. We'll start by writing the given information. So it is given that for iron, its atomic weight, we'll write AI is equal to 56. Valency of iron, let's write it as valency of I is equal to 2. The current for iron is given to be 1000 ampere, while the efficiency of current is given to be 90%. Now for this information, the material removal rate is given to be 0.26 grams per second. Now information given for titanium is atomic weight, let that be 80, is 48. Valency for titanium is 3. Let current for titanium be IT. It's given as 2000 ampere. And efficiency of current is given same for titanium also, which is 90%. For this information, we need to calculate the material removal rate for titanium. Now the formula for material removal rate in terms of all these given quantities is as current passed into the atomic weight of material divided by Faraday's constant into the valency of the material into current efficiency eta. So we have for iron, we can substitute these given values and find out the Faraday's constant. Faraday's constant has a unique value, but if you don't remember that unique value, you can find it out using the information given for iron. So let's find out. Faraday's constant here will be F equal to current for iron is 1000 into atomic weight of iron is 56 divided by valency for iron is 2. Material removal rate goes in division on right hand side, which is 0.26 grams per second, and efficiency of current is 90%, so we can write this as 0.9. When this is calculated in digital calculator, we get the Faraday's constant to be 96,923. Now let's use this Faraday's constant. It's the same formula applied for titanium. So we have material removal rate. Of course, this is for titanium, will be equal to current for titanium is 2000 ampere. Atomic weight of titanium is 48 divided by Faraday's constant that we found out is 96,923 into valency of titanium is 3 into the current efficiency for titanium is also 0.9. It is 90%, so numerically it is 0.9. When this is calculated in the digital calculator, we have answer as 0.297, which is almost equal to 0.3 grams per second. Let's go back and mark the correct option. The expected material removal rate for titanium in grams per second is given in option C, 0.3. To learn more about electrochemical machining, you can refer to the NPTEL video, Electrochemical Machining Processes, ECM. You can also find the explanation of the formula that we have used here for calculating material removal rate in this reference. This reference is from the course Manufacturing Process Technology 2 by Professor Shantanu Bhattacharya. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.